it? 8. Lecture 7. Question number 8 नहीं हुआ है. Show me. हाँ. अच्छा. So, did you attempt it? Did you get the answer? So I think in question number 8, it's something like this. You have a mirror here, and then you have a screen here. There's a source here, which is at 1 millimeter from here. This distance is given to be 5 centimeter. This is given to be 5 centimeter. Or rather, let me take extreme rays and let me first find where is my second source. The virtual source. I think it will be found somewhere here. S2, S1, and this distance is also 1 millimeter, no? Yes or no? So then, what is this distance given to be? 5, 5, and then 190. Let me give some names. So, this is O, this is R, this is Q, and this is also 1 millimeter, na? Yes or no? This is also 1 millimeter. And now they have asked you to find RQ is equal to what? This is the A part of the question, na? What is RQ? So, अच्छा, these are not the best of the rays. तो मैं थोड़ा अच्छे से rays बना देता हूँ. I think the rays should be then at least something like this. Is it okay? थोड़ा सा ठीक है diagram, I think. Good. To find this RQ can be written as OR minus OQ. क्या? Look at this. RQ is equal to OR minus OQ. But how to find OR and how to find OQ? For this, we will use similarity argument. So this whole thing is about geometry. Yeah? So tell me which two triangles are similar and how can I find this OQ? Let me take this triangle and then let me take this triangle. Are they similar? If they are similar, then by BPT what can I say? So let me name some points.
Can we also consider the above triangle?
Yes, we will consider that as well. So ये A, B, and let me call it C. So taking triangle QAO and triangle QS2C. बताओ, by BPT what can you say? QO by QC should be equal to AO by S2C? Yes or no? QO by QC should be equal to AO by S2C. And I think from this I can find OQ, na? What is OQ then? What is AO by the way? 190. And what about S2C? 200. So that's 190 divided by 200 into what is QC? QC can be written as QO plus OC, na? And what is, that's OQ plus 1 millimeter. And now you do this algebra. तो बहुत simple है. I think ये 119 by 20 multiply by OQ goes to the other side. 1 minus 19 by 20, that's 1 by 20. 1 by 20 OQ is equal to 19 by 20. So you'll get 19. Can I leave the calculation to you? Even though I just said everything, I think it will be something like 19 millimeter. That's 1.9 centimeter. And we found successfully the OQ. Considering these two triangles, what can you consider then? The above two, and then you can find OR, na? OR, RO, whatever. So I think I will take this triangle and I will take this triangle. Triangle RBO and triangle RS2C. Taking triangle RBO and RS2C. बताओ अब क्या होएगा? What should I write now? I think it should be RO by RC should be equal to OB by S2C. RO by RC should be equal to OB by S2C. But what is OB? What is OB?
185.
That's 195, na? And what about S2C?
200.
That's again 200. And now I can find OR. That's 195 divided by 200 into RC. But RC can be written as RO plus OC. Yes. And now you do the calculation again. तो ये बताओ ये हो जाएगा 1 minus 195 divided by 200 OR. That's equal to 195 divided by 200. And now ये LCM लो. I think that will get 5 by 200. 5 by 200, 200, 200 goes. And then what will you get OR to be? 195 by 5. Is it okay if I skip some steps? Yes. So you check it later yourself that OR should be equal to 195 divided by 5. And what is this coming out to be? 39, na? 39 millimeter, but then in centimeter? 3.9 centimeter. If this is so, then what should be RQ? That's OR minus OQ, and that will come out to be? RQ is equal to OR minus OQ, that's 2 centimeter. It's as simple as that. Do you understand the A part of the question? I think there's a B part as well, no? In the question, it was just geometry. You just have to apply geometry and you will get the answer. What about the B part? You have to find the number of fringes that are formed. But now look at this. If I have this space, and in this space let's say one fringe forms, then another fringe forms, then another fringe forms, and how much width will be of this fringe? That's beta. That's beta. So this is 1 beta. This is also 1 beta. This is 1 beta. And then in total 3 beta, na? For 3 fringes. What if there are n fringes? N beta. So what is this length, by the way? That's RQ, na? The region in which the whole thing can be. So RQ can be equal to n beta. Batao. Yes. And based on that, can you find the number of fringes? Now it's very simple. You just have to find beta. And what is beta equal to? What is beta equal to? Which D and which D? Lambda capital D by small d, na? Yes. And now you just substitute and get the answer. So the B part is n beta should be equal to RQ. But what is beta? Lambda capital. अब बताओ values बताओ lambda. 5000 angstrom 10 power minus 10. Capital D कितना है?
200 centimeters.
200 into 10 power minus 2. And then small d कितना है?
2 millimeters.
2 millimeters है. That is the distance between.
S1 and S2.
That's the distance between S1 and S2, na? That's 2 millimeters. And that is the small d. Yes or no? That's not 1 millimeter. So that's 2 millimeter. So I should write 2 into 10 power minus 3. तो बताओ इसका simplification. 10 power 3, 10 power minus 10, 10 power minus 7, minus 7, minus 5, minus 5, minus 7 again. But then 3 goes up. Minus 4. And then 1 by 2. That's 0.5. Wait, कोई mistake कर रहा हूँ क्या मैं? Let me check again. Power minus 7.
So 5 into 10 to the power of minus 4.
वो आ रहा है क्या 5 इंटू 10 पावर हाँ -4 in meter and that will be what 0.5 millimeter or maybe I can write 5 centimeter है ना 5 centimeter ही है ना ये नहीं रुक जाओ this can be written as 0.5 millimeter 5 centimeter ही होना चाहिए ना
Sir, 10 millimeters is 1 centimeter.
ये बताओ मुझे ये that's 0.5 into 10 power -3 meters that's 0.5 millimeters 1 millimeter is how many centimeters
1 centimeter is 10 millimeters.
1 centimeter is 10 millimeters so this will be what
That's
no it will be 0.05 I think हाँ ये सही है ना मैं इतना सब क्या कर रहा हूँ 0.05 सेंटीमीटर्स इट्स करेक्ट देन व्हाट इज n is r by beta but what is r that's 2 centimeter divided by 0.05 centimeter and this will come out to be what 40 so there are 40 fringes in this thing 40 bright fringes do you get this ये तो एम्बैरेसिंग था मिलीमीटर से सेंटीमीटर नहीं हो पा रहा था बट एनीवेज आर यू ओके विद द क्वेश्चन गुड कॉपीड एवरीवन हैज कॉपीड करो डिड यू अंडरस्टैंड द प्रोसेस टोटली ज्योमेट्री whenever ये mirrors आएंगे ना then most of the times we will use ray diagrams and that will hint towards geometry yes got it then we can start with something new a new type of question now what if you have slits in front of slits then what happens so question is what if there are slits in front of slits ठीक है and it's best to do the question and then try to explain how it goes so let me give you the diagram of question number 9 from sheet and based on that I will explain I will do that question number 9 question and you have to do the 10th one yourself okay so sheet question number 9 and the situation is something like this I have these slits and let me call them so S1, S2, S3, S4 and then the final screen. This will be my screen 1 which you can think okay, there are holes in the screen now and that acts like a slit and this is screen 2. And now they will ask we already know what will be the intensity distribution on the screen 1 na? That will follow something like I equal to 4 I naught cos square phi by 2 where phi is the phase difference between the two waves and considering that the two intensities are equal then you can say that okay we already know what will happen on screen 1 what will happen on screen 2 that we will try to find okay and the question is you have this kind of setup and this is y from the center line and this distance I think one of the distance is given to be
The center line passes through S3.
yes center line passes through S3 so let me just check yes both of these distances are given to be capital D and capital D okay this is given, and this is given to be small d. Is it okay? These things are given, and now they are asking you to find read the question number 9, please. Read the question number 9. I am giving you 2 minutes to read. Read the whole thing. Do you understand what they are asking? They are basically asking what is the ratio of Imax by Imin on this screen. On this screen. But what was the formula of Imax by Imin? That's root I1 plus root I2 divided by root I1 minus root I2 the whole square, where I1 and I2 are the intensities from two sources. Those slits will act like sources. Yes? So whatever is the intensity that we find at S3, that we will call either I1 or I2, and whatever we find the intensity at S4, that we will call the other thing. So let me just give the names. So say I1 is equal to I, which is coming from the slit S3, and I2, which will be I, which is coming from the slit S4. Those slits will basically act like sources. Yes? And now you have to find I1 and I2. I think you can already guess what should be IS3. It should be 4I0. Why? Because it's lying on the center line. And at the center line there is a maxima. And what is the intensity of every maxima in interference? Everything has 4I0. So IS3, I can already guess it's 4I0. How to find IS4? So IS4 के लिए we will try to use all the conditions given to us. ठीक है? Remember that intensity at any point is given by the function which was 4I0 cos square phi by 2. And if you remember, you should know the phase difference. But how is the phase difference related to path difference? 2 pi by lambda delta x. Yes? And what was the delta x in this kind of experiment? That was d sine theta. But if you apply this small angle approximation, then this sine theta can be approximated to y by capital D. dy by capital D. And now do you understand? I think many y's are given to you. You substitute that y, get the delta x. Once you get the delta x, find phi. Once you find phi, you get the intensity. And once you get the intensity, that is the IS4. Once you get the IS4, you substitute and find Imax by Imin. So let me do it step by step. For A part, what is the y given? For A, y is given to be lambda d by 2d. If this is so, then what is delta x? This is this, then substitute. अब बताओ कैंसिल होएगा कुछ चीजें? And what is the thing that you get? Then what is phi? That's 2 pi by lambda delta x. And now 2 pi by lambda. What is delta x? So this will come out to be pi radians. Now I need to use this phi in this function. That's cos phi by 2. And then what is cos pi by 2? What is cos pi by 2? That's 0. So what should be the intensity? 0. So what is the intensity when y is equal to this at S4? 0. So that will not contribute anything. So that will be intensity at S4 is equal to 0. So I got my I1 and I2. Now I can find my Imax by Imin. What is my Imax by Imin? That's root of 4 I naught minus plus 0 divided by root of 4 I naught minus 0, and take the square. And what will this come out to be? 1. Basically 1. Is it okay? Do you understand the steps that I'm using? Whatever you find pattern on the screen 1, if you put different holes in different places, that will act like slits, and you already know what is the intensity at those holes because you know the intensity function. That holes will act like sources of that intensity and then make something on the screen too. Yes or no? Are you understanding the theory? Should I repeat it once? You have this 2 slit. You know the pattern that you will find here. The pattern is governed by what function? This function. It's given by that function. If for some reason you make 2 holes or any number of holes, you know the intensity that you will find at this point? You know the intensity that you will find at this point? You can find it by finding the phase. If you know the phase, you will find the intensity. So this slit will act like a source with that intensity. Do you understand? That slit will act like a source with that intensity. You can do the same thing here as well. And now they act like 2 sources that gives off that intensity, and then you will find something here. Are you understanding? बोलो, कुछ convinced faces नहीं दिख रहे मुझे. How many of you understood it? How many of you don't understand it? क्या नहीं समझ आया बोलो. क्या चीज?
What if one of the slits are present at the point when there is a dark center?
Okay.
Like we won't have.
Then that is what we found here, na?
So how do we even have a pattern on it too? Because it's
You don't get a pattern, na? Imax by Imin is coming out to be same. Is there a pattern now? It's not a pattern. Do you understand? So, if you have understood it, then try the B part yourself and give me the answer of Imax by Imin. Yes, it's coming out to be infinity. Now go for the C part. Incorrect. Okay, why are you so sad? Your friend left you. Hey, उधर क्यों बैठ गया? अच्छा, झगड़ा हो गया. कोई बात नहीं. Which one?
Second.
I don't apply a1 plus a2 formula. Apply the formula that I have given. Root I1 plus root I2 the whole square. Root I1 plus root I2. Go and sit there. Third bench. Yes? B is undefined. What about C? B is correct. Everybody got that B is infinity? Yes. C part निकालो. हाँ, give me root 2 की value substitute करो और उसके बाद give me a final answer. Yes, approximately 34 is correct. सो जाओ. Yes, so let me do the b part as well. बताओ b part का value कितना है? So what was the y for b? So y is equal to lambda capital D by small d, na? Then delta x is not delta x. What were we finding? हाँ, delta x से निकाल रहे थे ना? Delta x was y small d by capital D, and y is lambda d. If this is lambda, then phi is equal to 2 pi, and then cos phi by 2 is cos pi. That's minus 1. And then you take the square of it in the intensity. And you will get basically plus 1. And that is the intensity of the slit 4. If intensity of slit 4 and intensity of slit 3 are matching, what will happen in the denominator? Blows up. Blows up, goes to infinity. Is it okay? That was the B part. What about the C part? What is y this time? 4d है क्या? 4d? Then what is delta x? That's lambda by 4. And what will be phi? That's pi by 2. Then cos phi by 2 will be? Cos phi by 2 will be 1 by root 2. Then what will be I? 4 I naught into 1 by 2. That's 2 I naught. And then what will be I max by I min? That will be something like 4 I naught root plus root 2 I naught divided by 4 I naught root minus root 2 I naught square. This will come out to be 2 plus root 2 divided by 2 minus root 2 ka square. And now you do some simplifications. At the end you should get 34 approximately. Okay? Do the simplification yourself. And please put the value of root 2 maybe. I was trying to get without even the value of root 2, but शायद नहीं होएगा. But anyways, this was question number 9. Did you understand ki how to attempt these kinds of questions? Now I am making the diagram of question number 10. Note it and take it as a homework. And if you are not able to do those questions, it's okay. In some study hour, I will explain the question number 10. But sheet ka question number 10. Let me make the diagram. These things are given. Anything else? No, I think nothing else. Okay. So note the diagram and then attempt it later yourself. It's same as 9, so let me even write that. Same as 9. Okay. If you have drawn the question number 10 का diagram, then attempt question number 11 yourself. I will wait 3 more minutes and then I will start with question number 11. Huh? You don't need any diagram for it, you have to make it yourself. Socho, socho. कल का क्या? वो तो मैंने बस दिया था तुम लोगों को काम करने के लिए, अब वो मैं वो भी डिस्कस करूँ? क्या चाहिए? कोई अच्छा दिया था मैंने, कल दिया था ना? अरे क्वेश्चन 4 का ही डायग्राम था वो बस, और कोई शीट में और कोई डायग्राम है ही नहीं। बाद में, अभी लेक्चर नहीं, बाद में।
Answer is in terms of lab.
Yes, answer.
4 lambda.
Incorrect. Anybody else? Should I start or should I wait?
Lambda by 2.
Incorrect. Root 15 lambda. Incorrect. You are off by a factor. No, not even off by a factor. It's totally wrong. Should I start? बताओ कुछ ओपिनियन दो भाई, हाँ या ना? Start. 1 minute. ठीक है, एक और मिनट रुक जाते हैं. Incorrect.
Sir, why is lambda in this case? Why is lambda?
Why is lambda? No. Okay then, let's start with this question number 11. And the question number 11, I think the information given is there are two sources S1 and S2 emitting light of this. Separation between the sources is 2 lambda. Yes? So let me make the diagram. It's something like this. No? You will have a screen where the separation between these two sources is 2 lambda. If I take the center line, then what is the distance from here? This is lambda and this is lambda, na? Yes? And now they are saying ki what is the smallest distance on this line? Acha, consider a line passing through S2 and perpendicular to the line S1 S2. Let me make this S1 S2 line, and now you consider a perpendicular that's going to touch the screen somewhere. Let's say at some point P. Okay, and let me connect this point as well, and let's say this distance is x. And this S1 S2 length is given to be 2 lambda, na? That's 2 lambda. What they are asking then is ki acha, what is this length then, by the way? S1P? That's 4 lambda square plus x square, na? Okay, anyways, this is given to be a perpendicular. What they are asking is what is the smallest distance on this line from S2 where a minimum of the intensity occurs? Dekho, minimum will occur like this. There are many minimas. There will be a first minima here that will occur at delta x equal to lambda by 2, na? Yes? There will be a second minima which will occur here, delta x equal to 3 lambda by 2. There will be a third minima which is delta x equal to 5 lambda by 2. Yes? Which of them has the smallest distance? तो अगर ये slit इधर से देखे, which of them?
3 lambda by 2.
3 lambda by 2. Do you understand why? This is 1 lambda and this is half of it, and this 1.5 is a little up, and then 2.5 is even more up. So which of them is the closest? 3 lambda by 2. So what should the S1p minus S2p equal to? S1p minus S2p is called the path difference. Yes, and this is coming out to be, that's delta x 3 lambda by 2. What is S1p? Root of 4 lambda square plus x square. What is S2p? That's x. Can you find this x now? It's a very simple job. You just square it, and I think you can take the plus x on the other side. 4 lambda square plus x square, which is equal to 3 lambda by 2 plus x the whole square. We take the square, 4 lambda square plus x square, and now it's just a matter of algebra. But did you understand the idea? What I did, how I made the diagram, did you understand that? Once the diagram is done, then the whole thing becomes very, very simple. Yes? And this is how we get x to be 7 lambda by 12. That's just a matter of simplification. But do you understand why I am picking only 3 lambda by 2, that minima? Because that corresponds to the smallest distance, huh? Good. So now that we have done question number 11, I will skip question number 12 right now. We will do it some other day. Question number 10 we will do in a study hour, but take it as a homework for now. Otherwise, I think question number 13 to 16 are done already, and 17 to 22 are of polarization. I am skipping polarization right now, so we can move to a new chapter then. Take a new page and we will start with modern physics. अभी भी लिख रहे हो बेटा? वो प्रतीक सर पढ़ाएंगे आफ्टर मे बी इलेक्ट्रोमैग्नेटिक वेव्स. हाँ, whenever he comes to this section and starts teaching. Okay? Yes. Can I go on? Is it done? Do the simplification a little bit yourself. Okay. So take a new page and write modern physics. Lecture 1. Modern physics. And let me list out the topics that I will go in the order that I will go. The first thing that we will study is atomic structure. Second is de Broglie wavelength. The third thing is photoelectric effect. Fourth, X-rays. And the fifth is radioactivity. And then the sixth is nuclei. This is the order in which I will go. So Can I start with the discussion? Most of the starting, so atomic structure, I think that's why I chose this chapter, because you have already studied in chemistry in depth, I think. So most of the things in the start I will just say them, and lot of things I think you already know. But we will try to give reasoning wherever it is necessary. But I will try to skip through some topics a little fast. Okay? So atomic structure. So the story goes like this, ki you have anything in the universe, and the basic understanding is you can break it, you can keep on breaking it until you get the smallest possible thing. And once you get the smallest possible thing, then you can join them all together and create some matter. You, me, this board, anything is made up of those things which are just taken together, and that creates this. And what are those small elements called? They are called atoms. And to understand, see, this idea of atoms or molecules were not so intuitive. Actually, even before this, the idea of electricity was already known, and the idea of charges was already known. But atoms and molecules ka jo idea hai, this idea of molecules, to be more precise, was only accepted maybe 100 years ago. Otherwise, people didn't even believe that molecules existed. It's only after Einstein came along and said that Brownian motion exists, and he showed it by theory that molecules should exist if Brownian motion exists. We are not going into that, but the idea is a little new as far as time goes. So the idea of electrons or charges was already known, and then we said if everything has charges, and that means this smallest elements should have charge, but the smallest elements should have a certain property. And what is that property? That they should be electrically neutral. What do you mean by electrical neutrality?
They shouldn't possess any charge.
They should possess charge, but the net charge should be 0. That means if there are n number of negative charges, there should be equal n number of positive charges. Yes, and the net charge is coming out to be 0. Yes, so in a sense, now you have a vague understanding of what should this smallest possible thing contain. It already, we have understanding it should contain some negative charges, some positive charges. Now the next thing is, how should they be placed? What kind of structure they follow, so that the things that we see in nature, they will be shown. So that is the next step, to actually understand what is the structure inside it. How are negative charges and the positive charges placed? And these negative charges, I will keep on calling them electrons. And the positive charges, I will keep on calling them protons. I think you have come across these words already. So then many attempts were made. One of the attempts was by Thomson. I think, I don't remember the date, but maybe in 1900s somewhere at that time, Thomson came and he gave his famous plum pudding model. And what was the model? Yes, you have these, the way in which I remember watermelon ka, you have these seeds, and those seeds are my electrons, I think, and the rest of the space is contained by protons, and this is how the thing is. Everything is mixed. What is so wrong in this? I think directly you can see there is something wrong. What is wrong? The two charges, see, in nature there are many forces, and I have told you there are 4 fundamental forces. One of them is electromagnetic force. But this charges, positive and negative charges, have some force in between them as well. It's called a Coulombic force of attraction. You will study it in electrostatics. But there is some kind of attractive force. If there is some attractive force, so they will keep on attracting each other until this distance keeps on decreasing. And then they will collide maybe. Or maybe they will merge into whatever happens. But this doesn't seem like so good. Because the atom will just explode. Or maybe something happened, but it's not stable. So this is not so good. And then came his student, his PhD student, Rutherford. Rutherford came, I think, in 1911 or 10, something like that. Rutherford came and he said he did an experiment rather. He didn't say anything, but rather he based his results based on experiments. And what was the experiment, do you remember? The alpha scattering experiment. Alpha scattering. And what was that experiment? You have an alpha particle. What is an alpha particle? A helium nucleus. Helium nucleus, right? He2 plus. He2 plus. What do you mean by 2 plus? Two electrons are stripped away. And now you have only the nucleus inside it, and that nucleus is positively charged. Anyways, you have this positive ion, and he used this positive ion to actually bombard it onto some kind of atom. What was that?
Gold.
A gold foil. And this is actually the way in which we do it still today. If you really want, if you have something, let's say, and if you want to find the inner structure of that or whatever is inside that thing, what do? You break it. The simplest possible thing is breaking it and then seeing whatever is inside. How do you break it? You bombard something. You bombard, and still this is the way in which we do it today. I don't know if you have heard this phrase LHC, that's Large Hadron Collider. And what do people do there? You bombard one particle onto the other particle to see what is inside the other particle. And that is the principle that he used as well. He used a positive ion and then he bombarded onto some kind of foil. And what did he find? Do you know the results? What were the observations?
When the alpha particles were going 180 degrees, there was no scattering.
No. When the particles were actually incident on this material, most of them just passed away. Most of them just passed away, and based on this, what was the conclusion that he made? Most of the atom is empty. But then he found in 1 in 10,000 something like this, 1 in 10,000, so books to books it varies, but 1 in 10,000, this atom, when a positive ion, when it went, it actually deflected by pi radians. It was going like this and deflected by pi radians. When will that happen? When there you have a positive charge and then another positive charge and it deflects it. It repels it. Yes or no? And he found that this doesn't happen so often. 1 in 10,000 cases. So that means most of this space doesn't even have the positive ion or positive charge. The positive charge is only situated in a very, very small space. And what did he call this small space to be? Nucleus. He said this atom is small and nucleus is even smaller. It's even much more smaller in it, and in that very, very confined space you have all the positive charges. He said that. So what were his conclusions? That most of the atom is empty and all the positive charge is confined to nucleus. And then he said one more thing. He said that there has to be negative charges, but how are negative charges moving? They are moving in a way in which the planets revolve around the sun. They move along in circular orbits, where if you are performing circular motion, you need a centripetal force. Who is providing that centripetal force? The nucleus is giving an attractive force. And if you have an electron like this, so there is an attractive force which is acting towards the center of the circle, no? And this is the force which is a centripetal force. And it keeps on revolving like this. These were the conclusions of the results of the experiment. He said these things. But what is so wrong here? What was wrong?
After some time, the electrons would be falling into the nucleus.
Why? Why would it fall? You have these electrons which are performing circular motion. Why would it fall?
It will lose the energy.
Now, why would it lose energy?
Keeps on rotating.
It's not rotating, it's revolving. It's revolving. And the result of, you will study it in electromagnetic waves. That is the last chapter. You will study that if you have a particle, a charged particle, if you have a charged particle Q and it oscillates, either it oscillates or it accelerates. Whenever it accelerates, it loses energy. I am not telling you how it loses energy, but it does lose energy when it accelerates, only in that case. If it is performing if it is moving in constant velocity, it won't lose energy. But if it is accelerating, it will lose energy. Is it accelerating when it is performing circular motion?
Yeah.
Even in uniform circular motion, is it accelerating? Yes or no?
Yes.
It is accelerating. Why? Because the velocity vector ka direction is keep on changing. There is acceleration. So it radiates, and when it radiates, it loses energy. When it loses energy, then this radius of the circle depends on the kinetic energy that you can maintain. If your kinetic energy keeps on decreasing, that means this circle the radius keeps on decreasing. And eventually what will happen?
It will fall into that.
You will spiral. You spiral and then you fall towards the nucleus. And do you know how fast this can happen? 10 power minus 8 seconds. 10 power minus 8, not even 1 second or anything. 10 power minus, as soon as you set up this thing, 10 power minus 8 seconds, this thing falls away. So is this a good model then? That's not even good. But some things are very noteworthy, that he said experimentally he found that there has to be all this positive charge confined to this. That's a very important result. So I breezed through the two topics of plum pudding and Rutherford. Is it okay? I will talk about Bohr theory in a detailed manner, but for now I'm just writing some things. Is the discussion okay? You have already studied all these things, huh? That's why I discussed a little fast. But is it okay? Good. So let me write some things, you write with me. So obviously I will write everything that I just said, but I won't give time, I won't explain the plum pudding model. So I'm going to write a little faster, so please be with me. Given by Thomson. And he said suggested that, let me write things directly from the book so that I don't mess up.
Can you also write it from the book if you have? Can you also write it from the book if you have?
Rotate.
Can you also write it from the book if you have?
I am writing here. No? No. It's okay. You can write if you want. Yes, this is the model, and I'm not writing any reasoning now. I think you have extensive notes in chemistry, so I'm just writing. Is it okay? Not giving any reasoning right now, but I already did when I was explaining. I'm not writing anything. So this is the plum pudding model. Done. Go for the other model, alpha scattering experiment. And what was the setup like? So let me just, you have this screen, something like this, huh? You have the screen, and here you have some kind of foil maybe. What was the foil? Gold foil, huh? Then you have this, ये क्या ZNS का screen था क्या? ऐसा ही कुछ तो था ना? It's a fluorescent screen, more importantly. What is the use of this fluorescent screen?
Only a few particles.
What is the use of this? Huh?
You could observe it properly, the particle.
The color changes.
You can when the particle passes through this or gets deflected anywhere, then it bombards it on the screen, and then you get brightness there. When you get the brightness, you can actually calculate the angle of deflection based on that. So it's used for finding the angle of deflection. Anyways, so let's say you have this source, alpha source. Acha, it's very interesting to see to understand later. I will try to relay the idea later, but why should we use only alpha source, or why is there an alpha particle to be He2 plus? Why not any other thing? Why not Li3 plus or anything else? It's very interesting to see, and we will see it later on when I will talk about radioactivity and how alpha particle arises, or why are they so important. We will understand it by B by A curve. But anyways, for now alpha particle is what we have, and this is a He2 plus nucleus. Yes, the particles bombards here, and I'm not writing anything more than this. I'm just writing the observations. The observations were what? One of the things that we observed was most of the times the alpha particle just pass through the foil, na? Most of the time the alpha particles just passed through the foil. What was the second thing? The second thing was 1 in 10,000 times the alpha particle got deflected by pi radians. 1 in 10,000 times the alpha particle got deflected by pi radians. Any other observation? That since, I will use that as a conclusion later. So these are the observations that we have, the basic observations. What could be the conclusions based on these observations? One of the conclusions could be that most of the atom is empty. Yes. And what is the second conclusion? That all of the positive charge is concentrated in a very small region, and we call the small region to be nucleus. Yes? Is it readable for everyone, by the way? I'm writing a little fast, so the handwriting is not so good, but hopefully it's readable. Number 3. He said ki if electrons are really going to exist inside the atom, then they will perform this circular motion. So that is the third conclusion. The electrons.
Sir, but how do we conclude that from the experiment?
See, the electrons are not, they can't be stationary for one point. If you are going to put them stationary, then we are back to the case 1. Yes? And they have to be somewhere. Na? So you can imagine ki you have one mass and you have another mass. If it is not falling towards the other mass, that means it has to be moving. But there is a force which is acting towards this. Na? So if it is going like this.
But at that time we didn't know that the force was acting towards to pull it down. Right?
Obviously we knew, because we knew that there were two one positive charge and a negative charge. And what is the, I did not tell you Coulombic force or anything, but by simple understanding there is an attraction between them. The same attraction that exists between two masses. Yes or no? Two masses. And then you can conclude if the masses, so our earth is not falling onto the sun, na? Then what is the thing that it follows? Follows some kind of closed orbit. Only then it doesn't fall into the sun, na? So it should follow a closed orbit as well. It just so happens that our sun follows, our earth follows an elliptical orbit, and here he said for symmetry that it follows a circular orbit.
But what if the alpha particle was too huge to just pass through that?
What do you
The
mean by
electrons
that?
were constant. Like even if they were not moving, the alpha particle.
Irrespective of alpha particle or not, if the electron is just stationary, then won't it fall? Who is holding it then? Has to keep on moving. If it doesn't keep on moving, then it will fall. And it keeps on moving in a circular orbit. This is what he assumed or concluded. The electron revolves around the nucleus in circular orbits where the necessary centripetal force is provided by electrostatic or Coulombic force of attraction. Yes, these were his conclusions. Once you have written it, then let me write the final thing. What is so wrong in the model? अच्छा यही लेके बैठे हुए फोटो इलेक्ट्रिक बैठे बैठे ये चैप्टर ही गलत है नहीं इधर की बात कर रहा हूँ अच्छा पढ़ चुके हो वेरी गुड पढ़ो पढ़ो अच्छा घर में कर चुके हो अच्छी बात है बोलो
The experiment that the nucleus is exactly at the center of the atom.
You can guess?
It can be like towards a bit towards
Yes, I know that. It can be anywhere, but this is what he guessed.
This assumption.
Yes, I think so. But I will have to check. I mean, maybe there's something with which you can conclude.
In which chapter is this Coulombic force of attraction included?
Electrostatics. That's not on this book.
Electricity and magnetism.
Pratik sir will teach you that. What is so wrong with this theory? What was the... No. It couldn't even explain the stability of atom. You can't go beyond this. At least your atom should be stable enough. The moment you give a structure, the structure should remain. That structure was falling apart. So an oscillating or accelerating charge loses energy in form of electromagnetic radiation. Thus, energy of electron keeps on decreasing and radius of circle keeps on decreasing as well, on decreasing continuously. Continuously. This is a very important word, huh? Continuously. I will come back to it when we will talk about the spectra and how this actually assumes a continuous spectra, but in hydrogen we find a line spectra, discrete one. I will talk about it later. एक मिनट, pause it. हमें keeps on decreasing continuously and eventually the electron spirals and falls onto the nucleus. So couldn't explain stability of atom. ठीक है? As soon as you have written this, you can take the break and you can turn off the video.